Patterns in Algebra. Hi class! Great and blessed day! Our lesson for today is about quadratic function. Learn something from our video lesson. Our learning target is to represent a quadratic function using table of values, graph, and equation.
Let us define first quadratic function. A quadratic function is of the form f of x is equal to ax squared plus bx plus c, where a, b, and c are numbers with a is not equal to 0. Quadratic functions can be represented in a number of ways. First way is using table of values. Example number 1. Construct a table of values for f of x is equal to negative x squared minus 2x plus 1. For the solution, the independent variable of the given quadratic function is x. When we say independent variable, we can always change the value of x. Let's say if x is equal to negative 3, we change the value of x as negative 3 by substitution method. And now let us evaluate the resulting expression. The quantity negative 3 squared is equal to positive 9. Then 2 times negative 3 is equal to negative 6. Then we add 1. Performing the operations, we now have negative 9 plus 6 plus 1 is equal to negative 2. Then f of negative 3 is equal to negative 2. If x is equal to negative 3, then y is equal to negative 2. What if x is equal to negative 2? Change all the values of x be equal to negative 2. Now, we simplify the expression. Okay, class, what is the quantity negative 2 squared? Correct, it is 4. How about 2 times negative 2? Yes, it is also correct. It is negative 4. And then add 1. We can cancel negative 4 plus 4 because it is 0 pair. Then the answer is 1. We have negative 2, 1. Another value of x is negative 1. Again, change all the values of x be equal to negative 1. Then we have negative 1 minus negative 2 plus 1. Then the answer is 2. Again, we can cancel negative 1 plus 1 because it is 0 pair. Then we have negative 1, 2.
This time, you are going to answer on your own. I will give you 10 seconds and we'll check if you have the same answer. Your timer starts now.
Time is up! Now let's check if we have the same answer. Changing all the values of x equal to 0, we have 0 plus 0 plus 1 is equal to 1. Then we have 0, 1. Do we have the same answer? If yes, very good. Keep it up. If not, it's okay. Always remember that mistakes are proof of trying. So, let's keep going. Another, what is the function value of x in the given quadratic function? Your timer starts now. Time is up. The value of y when x is equal to 1 is negative 2. Then we have 1, negative 2 as an ordered pair. I hope you get it. Let's try another one. How about the function value of 2? The function value of x is negative 7. So therefore, when x is equal to 2, y is equal to negative 7. Lastly, the value of x is equal to 3. By substitution method, the answer is negative 14. So we have 3, negative 14. Take note that for every values of the independent variable is a corresponding values of f of x. The generated values of x and f of x can be tabulated as follows. Another way of representing quadratic function is by its graph. Example number 1. Graph the quadratic function f of x is equal to negative x squared minus 2x plus 1. For the solution, construct a table of values for x and y. The table of values for f of x is equal to negative x squared minus 2x plus 1 is given as follows. From the tabulated values, plot the corresponding points in the Cartesian plane having quadrant 1, 2, 3, and 4. Let us start with the first ordered pair. Negative 3, negative 2. Next ordered pair, negative 2, 1. In quadrant 2. Next, negative 1, 2. In quadrant 2 again. Next ordered pair, 0, 1. In the y-axis. Another ordered pair, 1, negative 2. In quadrant 4. Next, 2, negative 7. In quadrant 4. And lastly, 3, negative 14 in quadrant 4. Then, draw a smooth curve connecting the points on the Cartesian plane. The graph of f of x is equal to negative x squared minus 2x plus 1 is a curve. Class, what do we call that curve? Okay, very good. That curve is called a parabola. This is the reason why quadratic function is also called parabolic function. Lastly, we can also represent quadratic function using equation. The parabolic structure allows the graph of quadratic function to intersect the x-axis in three different ways. It may cross the x-axis once, twice, or none at all. If the parabola intersects the x-axis, the ordinate of the point or points of intersection is 0. This is why the abscissa or abscissas of the point of intersection of the parabola and the x-axis, where the ordinate is 0, are called the zeros of quadratic function. The primary concern in finding the zeros of quadratic function f of x is equal to ax squared plus bx plus c is to find the values of x such that f of x is equal to 0. Quadratic equations can be solved by extracting square roots, factoring, completing the square, and using the quadratic formula. Example number 1. Find the zeros of f of x is equal to x squared minus x. For the solution, equate the defining expression of the function to 0, resulting x squared minus x is equal to 0. Since the expression is factorable, we use the factoring method. X squared minus x is equal to 0 by equating the function to 0. Then, by common monomial factoring, we now have x times the quantity x minus 1 is equal to 0. By applying the zero factor property, it implies that x sub 1 is equal to 0 and x sub 2 is equal to 1. Therefore, the zeros of f of x are 0 and 1. Show that 0 and 1 are the zeros of equation using Desmos, a graphing calculator application. From the given illustration, how many times does a parabola crosses the x-axis? Okay, correct. It crosses the x-axis twice. Class, remember that a quadratic function can be represented using table of values, graph, and equation. That ends our lesson for today. And if you do not have any other questions, you got one whole sheet of paper and try to answer the following questions. Represent the following quadratic functions using table of values, graph, and equation. Thank you for listening, and God bless us all.